Professor Coles. I'm just going to go over the part of the computing problem where we're going to use a Matlab script to generate the information needed by OpenFOAM to build a grid around an airfoil, 2D airfoil, to do some flow computations, which we'll handle in a later computing problem. So I assume I've downloaded my airfoil block mesh.m. This is a Matlab code. It's available on the My Courses website. Now, if you have access to Matlab, I'm honestly not sure if you do or don't, but if you do, like I have local Matlab here, I'll just start it. All I'm asking you to do is slightly edit the script and run it and keep the file that it generates. So I've started Matlab. I'm going to go to my desktop. Now you would normally do this by using Windows. I use the terminal for everything. I guess I go like this. So open. Okay, so now my Matlab's pointing to the desktop and I have this code here. So I'm going to edit it. Edit airfoil block mesh.m. This is taken from, hopefully we have credits to this person from Norway. I had to modify it a bit. It was originally a Octave code, but now it's Matlab. So he or she did all the work. Foil geometry. So we're dealing with, for the homework, a 2412, I think. 2412 foil. That's a Cessna 172 foil shape. So I'll switch it to that, and that's it. I won't change anything else. So I'm changing the foil shape. Whoever wrote this put in a foil shape generator. You can go ahead and look through the code. This is where it actually outputs into a file that OpenFOAM uses. And this is the section where it's generating the code, the NACA shape, and distributing the points along it. So I'm going to go ahead and run this with this green arrow. It should run. It's running. Okay, and it's done. So it produces a figure. This is the shape of the foil. If you looked at the foil sim part of the homework, you would have seen the same thing on that NASA page. And take a screenshot of that. So I'll just do like this. Okay, so I have a PNG file here. You see on my computer it's generated this block mesh dict file, which we can have a look at. Let's see, I'll open it with TextMate. And this is a input file for OpenFOAM. OpenFOAM reads this. Here's the vertices along the wing, generating blocks, generating a grid, and uses this to generate a mesh, which I'll show you right now if you have the patience to wait. Okay. So this would be in a later computing assignment. You're going to use OpenFOAM to compute flow over a wing, this 2412 wing, at a given angle of attack. And one of the input files OpenFOAM needs is to describe the mesh, and that's what that Matlab code generates. So open this, and then I'm going to add the mesh and draw it. I may have to slice it. So let's see. So it's a 2D solution, but again, OpenFOAM isn't ever technically 2D. It's just 3D with nothing happening in the lateral direction. Let me try to slice that. I can't even tell a coordinate. I'm supposed to slice it in X, Z, the vertical. Is it Y? I think it's Y. Okay, so operator slicing. Let's just try it. Nope, I'm going to 0.25. Okay. That's the mesh. It's a little bit hard to look at. I'm going to zoom in very close to the airfoil. And you can see the mesh is fairly compressed against the airfoil. This is still quite a coarse mesh. It's too coarse in reality to do for calculation like this, but I'm trying to minimize usage of the cluster to reasonable values until we get to the projects. But you can see basically in each one of these control volumes, again, it's solving equations for mass, conservation of mass and momentum, and that, if it's done correctly, will produce the right flow field, and from the pressure and shear stresses you can deduce the lift and drag on the vehicle. So let me zoom it back out again. So you can see the domain is quite far in the far field, and that's to get far field and reflection effects away from the airfoil. So it's truly, if you apply infinity conditions here or free stream conditions, they are truly free stream conditions because they're not feeling the effect of the airfoil at this location. So so that file you're creating in the Matlab script generates the information that OpenFoam needs to generate this mesh, which we call a C grid. It's shaped like a C. A C grid is a typical way of meshing an airfoil in such a way that you can resolve the boundary layer, not only the boundary layer on the wing, but you can resolve the wake. You have this region here to be able to resolve the wake as well. It's a C grid. So I'm going to delete that. We might as well just have a look while here. We could look at contours of pressure. Yielded no data. Pardon me for a second here. And let me slice that. Not sure why I didn't maintain my slice. Okay. And let me add pressure on top of that. Okay. So these are the pressure contours around this airfoil. I'm not sure what angle of attack I ran this at, 3 or 5 degrees. This is the 2412 airfoil. You see the peak suction here. Now pressure is relative to 0. Free stream pressure is 0. So green is roughly 0. Maybe we'll center it around 0. So put a minimum minus 2.4, 2.7, maximum 2.7. Y. Okay, green is now 0, or free stream. So there's less of free stream here. Blue, there's suction on the top of the foil. The highest pressure occurs here. This is the stagnation point where the fluid streamline comes in and directly strikes and stops in the airfoil. There's no stagnation point in the back. The pressure is increasing on both upper surface and lower surface as we go towards the back of the foil, but it never goes to 0. It's streaming off the back here. And if I add some vectors, I don't know if this will work or not, but we'll give it a try. Wow. 1 second. They are too big, aren't they? So let's scale them down. 1, about 0.5, about 0.2. Okay, and then we need more of them. Put them all. Is that going to look bad? It looks okay for now. And they are actually colored to the velocity magnitude. So let's, I think what I'm going to do, let's keep it like this. Let's get rid of my contours for now. They are mucking up. Oops, wrong thing. Contours there. Okay. So this is the velocity distribution over the airfoil. If I zoom in right in the boundary layer, you can see, it's hard to see. Let me go back and change the vector magnitude again. 1. Okay, so you can see the velocity. Actually, I apologize. Let me put the velocity distribution behind there. I'm going to make my vectors all black. And I'm going to put velocity, pseudo-color velocity magnitude. Okay, that's better. So we're coloring with velocity magnitude. In the back you can see the boundary layer where it goes to 0, and then you've roughly higher the free stream conditions out here. Free stream flow is 1, which is green. So you have roughly free stream flow faster than free stream flow up to almost a factor of 3 times the free stream velocity. 0 in the boundary layer. And as we go towards the trailing edge, you'll see that there's a wake formed here, right here. So see the velocity defect? Roughly free stream out here, slower than free stream, back to free stream. This is the wake of the viscous wake of the foil. That's about all I wanted to show you with that. Okay, so that's what you'll be doing in a later assignment using the file that gets generated from this Matlab routine. Okay, so again, turn in the foil, 2D foil with your homework, and that was Matlab running on my local machine. If you have a machine, I don't know, on campus, if you do or don't, and Matlab machines, it's the easiest way to do it, or on your own laptop, because you can just download the M file, run it, or edit it. That slight line, edit that. You can use external editors too. You don't have to edit from the Matlab. You can change, it's just a text file. You can change it any way you want, and then run it in Matlab if you don't want to use Matlab's editor. And then when it runs, it will produce this block mesh dict file, which is, don't change the name of this, will be dumped into the same directory wherever your M file started from. And put this somewhere aside for a later time, okay? And now I'm going to close this Matlab, and what I'm going to do is I think I'll end this session and I'll start a new one talking about using the virtual computer.